Namaskar. In the previous video, we have observed how to plot the function. We have plotted a bar is equal to y j cap plus z k cap. It was the diverging function, and therefore the divergence of a was 2. Correct? Now with the function which was given to the homework, that function was b bar is equal to minus z j cap plus y k cap. We will think about the significance of curl. But before that, again as usual, we will plot that function in Cartesian coordinate system. This is x-axis, this is y-axis and z-axis. And again, as we discussed last time, for simplicity, we will ignore the x-axis because the function itself is in yz plane only. But the same situation is for any position of x that is above the plane of figure and below the plane of figure. Just we will have to lower those lines. We are a bit familiar with plotting of the function, and therefore quickly I can plot the function at 0 1 0. It is 0 1 0, it is k cap, therefore it will be along z axis. At 0 0 1, that means along z axis with at 1 unit, it is minus j cap. Y is equal to 0, therefore it is minus j cap. At 0 minus 1 0, yes, it is 0, y is equal to minus 1, z is equal to 0, 0 minus 1 0, it is minus k cap, that means along negative z axis. And at 0 0 minus 1, it is j cap, correct? 0 0 minus 1, it is j cap. What will be the functional value at 0 2 0? It will be 2 k cap, correct? And similarly here the functional value is something like this, here it is something like this. Now you may plot by your own. At 0 1 1, that means at this particular point 0 1 1 0 1 1, that is minus j cap and plus k cap, therefore the function will be along this particular direction. Here the function like this, here the function is like this, and here the function is like this. Now you will realize that the function is cyclic, it is rotating about z axis, rotating about x axis in anti-clockwise sense, correct, from y to z. Means if I release some, suppose the water is circulating like this and it is represented by this vector function, and if I release some light objects, thermocol balls on the water, then you will realize that they will rotate about x axis, correct. Now as the function is independent of x, for any value of x along positive direction, we will have to lift the vectors in upward direction, and for negative value of x we will have to lower, but the rotation is as it is. The function is rotating about x axis in anti-clockwise sense. Now we will find the curl of this b bar, curl of b bar. Now in this time I will use the determinant method. Last time I was used the normal method to operate the del operator on b bar. Every term is operated on every term of b. But now I will write I cap, j cap, k cap. Here it is dou by dou x, dou by dou y, and dou by dou z. Then I will write here I coefficient is 0, j coefficient is minus z, and k coefficient is y. Therefore what is the coefficient of I cap? Dou by dou y of y minus dou by dou z of minus z, that is 1 minus minus 1, and that is I cap. Yes. Then it is for j, I will have to think about the derivative of 0 with respect to z, that is 0, and derivative of y with respect to x, that is also 0. And for k, I will have to think about derivative of minus z with respect to x, that is 0, and derivative of 0 with respect to y, that is also 0. And therefore just it is 1 minus minus 1, that is 2 I cap, correct, 2 I cap. Now again it is interesting, just to have observed that this function is rotating, it is curling about x axis, correct, curling about x axis, and it is from y to x. That means if the curled fingers of my right hand represent the sense of motion of the function, then the stretched thumb is along x axis, correct, the stretched thumb is along x axis, that is towards u. And therefore here the function rotates, and the rotation, if it is represented by a vector, it is along x axis, because in 12th when we discuss something about the rotational motion, Suppose the vector r bar rotates from this to this. This is the sense of rotation. Then the direction which is perpendicular to both, correct? This will be the direction. We have represented this as omega bar, or we have represented this as theta bar, actually small angle d theta, and it is omega, direction of the velocity vector, correct? If the velocity goes on increasing, the same will be the angular acceleration, and if the velocity decreases, the magnitude of omega is decreasing along this direction, then the alpha will be along opposite direction. And we are aware about the sense of rotation and direction, how to represent it. Therefore, this is a sense. It is anti-clockwise sense, but it is represented by direction, that is x-axis. Again, similar to the divergence. Right now, keep this magnitude 2 aside, but this will give you the direction along which the function is rotating. It is curling, correct? It is curling. Therefore, if the function has the ability to curl, ability to rotate, then it will give you the direction of rotation about which it is rotating, and obviously the extent of rotation, correct? The extent of rotation. For example, now you may think about z square j cap plus minus z square j cap plus y k cap. You can draw the function and you will realize that how it is rotating, what will be the extent of rotation, whether it is rotating with larger extent or not. Now, what is the physical significance? Suppose if I release some rod somewhere here. Suppose if I release a rod, this is a rod, correct? Then you will observe that at this particular point there is a force because of the function, therefore B bar is as if it is a force. It may happen that somewhere here also there is a force, but if the two forces are of different magnitude, then what will happen? Then the resultant torque is there, correct? Resultant torque is there. The rod will not move like this, but it will move something like this. Okay, that means along with the translational motion, there will be a rotational motion. Okay, that means if I release the stick anywhere in the field, it will rotate, and the rotation will be about positive x-axis. If I release the rod somewhere here, then again you will realize that what you will have to do, you will have to draw the vector function. Here the vector function will be something like this, here the vector function will be something like this. Again you will realize that along with the displacement, there will be rotational motion of the rod, and rotational will be in anti-clockwise sense, that means about the x-axis. In this case, it is independent of position, that means everywhere it is 2i cap. But suppose it is z square, then it depends on the present value of z. If it is higher power of y, then it depends on the present value of y2. And this can be treated as the significance of the curl of the vector function. Now I know that with this, it is not possible to think about the curl of a complicated function like this. We cannot imagine. But just to understand what is the meaning of curl of a vector function, we have considered a very simple vector function. Now typically in case of the magnetic field has the ability to curl, because in Oersted experiment we have observed that if the straight current carrying conductor is there and the direction of current is given by the stretched thumb of our right hand, then the folded fingers will give you the sense of magnetic field. I am not calling it as a direction of magnetic field, but it is sense, because everywhere the direction changes, and the sense is anti-clockwise, and therefore we can think about the ability to rotate, correct? That means magnetic field has the curl, the electric field has divergence, and there may be some situations where the field has curl and divergence both. If I think about such a random function, then it may have both. Now you may try to find the curl and divergence. I will give you a very simple function. Let the function p bar is equal to, this p bar is equal to, it is 2i cap plus 1j cap. Sorry, because better to give you in yz plane only. Therefore I can write it is 2j cap minus, say for example, k cap, correct? Plot this vector function and try to find the divergence and curl of this vector function. Then you will realize that whether this function has a divergence. By observing the nature of the function, by observing the plot for that function itself, you will have to gauge whether what will be the divergence and what will be the curl. And then by solving this formula, that is del dot p bar and del cross p bar, you can correlate. That means what is the divergence and what is the curl of that vector function. Thank you.